Okay, so hello everyone. So our today's topic is actually system of the linear equation. Okay, and we basically try to solving it by substitute. Okay, the substitute method. Okay, this is it's kind of like really important. Okay, it's really important topic. Really important topic. Sorry for the writing. So we got some really important information over here. Okay, so I will fully explain the substitute method in the problem, in the problem. Okay, but first over here, let's actually going for example first. Okay, and in the question part, I will I will tell you guys Okay, I will explain again. Okay, I will basically explain the substitute method over here again. Okay, but over here we got a really easy example to actually demonstrate how we actually using a substitute method. Okay, so just as the words is says, we are actually substitute those variable. Okay, so we have in equation 1 for this equation, and then equation 2 over here. Okay, so for all you have to know for substitute method, to applying substitute method is you trying to substitute. Here you can see we have y equal to 3x, so you basically substitute y equal to 3x into the equation 1. Okay, so that's basically what you do. Okay, so here let me actually show you. Okay, let me actually show you. So x plus y is equal to 12. So as you can see over here, y is equal to 3x. So you just substitute a 3x into the equation 1. Okay, so this is how is as the word as I say before, you basically substitute any variable into another equation. Okay, so as you can see, let's simplify a little bit. Okay, as you can see over here, after we substitute, all we got is x. So now so you are able to solve for x, right? So you are able to actually solving for x. So we have is 4x is equal to 12, x is equal to 3. Okay, as you can see, what we have is x equal to 3, and so after that you're trying to find y. Okay, the most easy one is the most easy equation you can find in y is basically y equal to 3x. Okay. 3 multiplied by 3 is equal to 9, right? Okay, so now we have find a unique solution. Okay, unique solution, x equal to 3, y equal to 9. Okay, as you can see, by using the substitute method, the problem gets solved really easily, right? Okay, so this is just a easy demonstrate over here. Okay, so now let's actually moving to the more important part. Okay, the more important part. Okay, so let me actually, so here we having a property. So choosing an appropriate method to solving a system. Okay, so by far now we already know 3 methods, right? So so let me actually write it down down below. Okay, we know totally 3 methods. We know the graphic, and then we know the addition, right? And then we know okay, let me actually think this page is kind of like really lax, so let me actually moving to the other side. Okay, so by far right now we already know 3 methods. We know the method of the graphic to solving a linear system, right? And then we know the additional method, right? Addition method, okay, and then we have here a new method which I just tell you guys. Okay, the topic over here is the substitute method, right? As I mentioned before, the graphic method is not useful. Okay, is inefficient. Okay, so you are actually not really concerned about using the graphic method. You are more focused on those two methods. Okay, because those two methods are really important. Okay, so for now we are only we are going to focus on only those two methods. Okay, the additional method and the substitute method. Okay, because those are the two methods. Those are the two methods you majorly using it to actually solving for a linear system. Okay, so here the property over here is you trying to choosing an appropriate method to actually solving an equation. Okay, so let me first read it first. Let me actually read it, and then I will give you some example. Okay, so the first one is say if one of the equation is already solved for x or for y, then substitute is the preferred method. Okay, and so the second one is say if the coefficient of x or y is the two equations are the same or opposite, then additional method is preferred method. Okay, so the 3 is say if solving for x or for y in neither is given equation result in fractional coefficient, then addition is preferred method. Okay, so let's actually explain each of them. Okay, now I will explain each of them. Okay, so 1, 2, 3. So I will explain the first one first. Okay, so the first one is say if one equation is already solved for x or for y, then substitute is the preferred method. So all that means the equation is something look like this. Okay, so suppose you have something like x plus 2y is equal to maybe 10. Okay, and then you having something like y is equal to 2x. Okay, so all of that meaning means you having something equation like this. Okay, okay, so let me repeat again with the so in the first one it says one equation is already solved for x. So over here this is already solved for x, right? Okay, so basically as you can see, as I tell you guys before, like you can basically right, this is already solved for x, so the substitute is the preferred method. Okay, so you just trying to memorize, like why you using substitute method, when substitute method is actually the preferred method, then the equation is something like this. Okay, so I will give you, and for the second one, is say if the coefficient of x or y is two equations are the same or opposite, then addition is the preferred method. So you forgot about those words. So you forgot about words and you're thinking about the equation. Okay, so whenever in this case, whenever the additional method is the preferred method, the equation is something like this. Okay, the equation is something like maybe 2x plus 3y is equal to 8, and then maybe on the other side what you have is something like maybe 5x minus 3y is actually equal to let me take a look, is equal to 5. Okay, so that's basically the meaning of the second one. Okay, there's actually not many explanation over here, because I think you guys don't understand it, right? So as you can see, two equations are the same or the opposite. In this case, it is opposite, right? It is opposite, right? The coefficient of the x or the y is the same. Over here we having the coefficient of the y is the same, right? Okay, so the coefficient is the same, but the coefficient is actually the positive. It's actually the opposite, right? So here, everything for the statement 2, what he say is that the coefficient is going to be the same or opposite. Over here, as you can see, the coefficient for the y is actually the opposite. So the additional method will be a preferred method. Okay, so let's talking about the number 3. Number 3, so basically for number 3, so basically for number 3, the statement 3 is basically talking about like the given equation result is in the fractional coefficient. Okay, is in the fractional coefficient. Okay, so all that means that the equation is something like this. Okay, so we have something like maybe 5x plus 3y is equal to maybe 4, and we have something like maybe 2x plus 4y is equal to maybe 3. Okay, something like this. Okay, yeah. So the statement 3. So here you can see for statement 3 we got in some fractional coefficient, right? So some fractional coefficient. Okay, so that's let me take a look again. Yeah, so as you can so basically so whenever you see something some fractional equations, then the additional method will be the preferred method. Okay, so yeah, so alright, so basically everything, for all of those statements, on which condition you are actually going to using the substitute or the addition. Okay, so that's now let's actually move into the. So now I have already explained everything. Okay, so now let's actually get some practice and how we can actually apply this condition, and then to determine which method will be preferred to use. Okay, so we basically got how many questions? I think I got 4 questions over here. Okay, so now is the time for you to actually, if you think some question is easy for you, feel free to skip it. Okay, feel free to skip it. Otherwise, I will talking all those questions in detail. Okay, I want to make sure everyone know how we actually applying, how we basically applying the property upwards. Okay, so if you still a little bit confused, then thinking about it for a moment. Okay, if you still a little bit confused, then thinking about it a little bit for a moment. Okay, or go back for this lesson again. Okay, so the first one, as you can see, we try to using the substitute method, right? So here solve each system by substitute. So so let me actually zoom in a little bit. So as you can see, as you can see, for equation 2, this equation over here, this is already solved for x, right? So this one is already solved for x. So basically, all you have to do is we having 8x and then we have minus 4. So all you have to do is plug in y. Okay, plug in y. So over here, all we have is y equal to 2x minus 4. So you just replace y. You just replace y with x in equation 1. Okay, so now for now you just simplify it. Okay, ax okay, minus another ax, I guess. Let me take a look. Right, minus another ax and then plus 16 is equal to 16. Okay, so let me take a look. Ax equal is get cancelled. 16 is equal to 16. So as you can see, the final statement what we have is 16 is equal to 16. So that's basically mean since over here we don't have a unique solution. Okay, so first of all, you know that there's no unique solution. There's actually no unique solution over here because the variable is gone, right? So you can see the variable is get cancelled. No unique solution. Okay, if there's no solution, then we have to state it is inconsistent or it's inconsistent or dependent. As you can see over here, is 16 equal to 16. So that means the system over here is a dependent. Okay, the system is dependent. Okay. Okay, so that's so here 16 equal to 16 means it is dependent. Okay. So if you having some statement something like 5 equal to 16, as you can see, so if you getting a statement, if you getting something like 5 equal to 16, so you know that it's inconsistent. Okay. But if you getting something like 16 equal to 16, that means they are on the same line. Okay, that's why you're getting those values are the same thing. So that means the line that's only all the point is actually on one line. So that means it's dependent. Okay, but if you getting some statement something like this 5 equal to 16, then you see the value are different. It's like separated. It's actually separated, right? Separated means it is inconsistent. Okay, it is inconsistent. Okay. So let me actually maybe I need to remove this part. Okay, because this is those are kind of like additional method. I mean this are additional. I don't want to confuse you guys, so that's why I remove it. Okay. So now. Let's move into the next question. Okay, so the next 3 problem is basically here is basically how we using neither the additional method or the substitute method. Okay, here say solving each system by using neither addition or substitution. Okay, if a unique solution does not exist, state that the system whether it's dependent or inconsistent. Okay. Okay, so here we have to decide which method we have to use over here. Okay, so let me think about it. Okay, so let's do question 2 first. Okay, so question 2, you evaluating, you take a look about the solution, the question, right? So we have equation 1 and then equation 2, and then you see we having positive 3y and then negative 3y over here, right? So as I mentioned before, over here the the coefficient of the y, is actually the opposite, right? So that means additional method is preferred, right? Addition is preferred, right? Additional method is preferred. So all you have to do over here is you using 1 plus 2. Okay, you're using 1 plus 2. Let me actually rewrite it. Okay, it's not that difficult. You just take a look about the question, so you will know which method we actually have to use it. Okay, so x plus 3y plus 2x minus 3y is equal to 12 plus 6. Okay, minus 3y, positive 3y get cancelled. X plus 2x is actually 3x. 3x is equal to 18. X is equal to 6, right? X equal to 6, and then you plug into the easy equation, right? So I think the easy equation over here is actually equation 1. So you plug in x equal to 6 into equation 1. Okay, so let me write it down. Equation 1, and then 6 plus 3y is equal to 12. 3y is equal to 6. Y is equal to 2. Okay, so let me take a look. Yes, so as you can see, we have a unique solution over here. Unique solution. X is equal to 2. Y equal to x is equal to 6. Y equal to 2. Okay, so now this problem gets solved. Okay. So this is basically the logic, right? So those basically the logic. So now let's move into question 3. Okay, so question 3, as you can see over here, we having this equation. So we having equation 1 and then equation 2. Equation 2 is already solved for x, right? Equation 2 already solved for x. So you know that the substitute method will be a good method to use it over here, right? Substitute is good method to use it over here, right? So basically you plug in. So over here what we have is y equal to negative 5x plus 3. So you basically you just replace it, you just substitute it, right? Okay, so that's basically all you okay. So basically what we have is tan x, let me actually write it down, okay, plus 2y equal to 7. So we replace y to negative 5x plus 3 equal to 7. Okay, so now you simplify it. Tan x, let me take a look, is negative tan x, and then plus 6 equal to 7. Okay, let me take a look again. Okay, yes, yeah. So tan x and then tan x get cancelled. All we have left is 6 equal to 7. So as you can see over here, we don't have no unique solution, right? So obviously it's no unique solution. So we have to determine this system is inconsistent or it is dependent. As you can see, the final statement over here, what we have is 6 equal to 7, right? And this statement is actually wrong. 6 is actually not equal to this, not equal to 7. Okay, so as I already show you guys, what is the difference between the inconsistent and the dependent. Inconsistent basically means the two number. The statement is actually a false statement. Okay, inconsistent basically means here the statement is 6 equal to 7. That statement is wrong. So it's kind of like two separate paths, right? So it's kind of like two separate paths. So that means that's therefore the system over here is actually inconsistent. Okay, the system is inconsistent. Okay, the system is inconsistent. Okay, so if you see something like 7 equal to 7, if you see some statement like this, 7 equal to 7, then you know it is actually dependent. Okay. Okay, but okay, so that's an example. Okay, that's basically an example. Okay, so if you see some statement something like 7 equal to 7, then it is dependent. Okay. Let me actually erase this part. I don't want to make any confusion. Okay, I don't want to make any confusion. Okay, so that's basically that's basically the solution for question 3. Okay. Let's move into the last question. So the last question. So the last question over here, since this one is the last question, so pause the video and then try to solve this problem by yourself. Okay? Plus the video. Okay, now let's solve the question together. So to first of all, we have to determine which method we have to use, neither addition or substitute, right? So basically over here you know that in order to using substitute, we need to have some equation which already solve for y or x, and then you didn't see you don't see that over here, right? So you don't see that over here. So you know over here we have to use so here let me actually write it down. No equation. No equation is already solved for x or y, right? So there's no equation is already solved for x or y over here. So you know we have to use additional method, right? So we have to use additional method over here. Okay, so as you can basically as you can see over here, another reason if you want to using the additional method is actually because the fractional coefficient, right? So the fractional coefficient, right? So as you can see, the fractional coefficient, right? Because you can see over here, if we multiply by we have an equation 1 over here and then equation 2 over here. So if you actually multiply by 3 on equation 2, okay, so you multiply by 3 on equation 2. Let's simplify a little bit. So what we have is negative 3x and then plus 15y is actually equal to negative 15, right? Okay, and then we call this equation is actually equation 3. So now you can see that for the equation for equation 1 for equation 1 and then equation 3, now we having x, we having the coefficient of x is actually positive, is actually opposite, right? It's actually opposite. So we basically have to use the additional method, right? So the next step what you have to do is you're using equation 1 multiply add, okay, equation 1 add equation 3. Okay, maybe actually move it down a little bit, and then what we have is 3x minus 2y and then minus 3x plus 50y is actually equal to 15 and then minus 15. Okay, 15 divided by 15 minus 15 is equal to 0. Okay, 3x and negative 3x is get cancelled. Okay, let's actually move it down a little bit more. And then what we have over here is negative 2y plus 15y, which is 13y. right? 631 is equal to 0. Okay, so let me take a look. Okay, and then finally what we find is y equal to 0, right? So what we find is y equal to 0 as the variable for y, right? And for now you are trying to substitute any of the equation 1 or 2 to actually so you try to find the most easy equation to find x, right? And I think over here both equation 1 and equation 2 are actually quite easy. Okay, so let's actually plug into equation 1 to find x. Okay, equation 1 is 3x minus 2y is equal to 15. Okay, 3x minus 2y is equal to 0 equal to 15. Okay, so this part is already equal to 0. 3x equal to 15. X is just simply equal to 5. Okay, so let me take a look. X equal to 5. Okay, x is equal to 5. So as you can see, for this problem we actually having a unique solution, right? So we having a unique, let me move it down a little bit. Okay, unique solution, x equal to 5, y is equal to 0. Okay, so since this is actually a unique solution, so we don't have to state it inconsistent or dependent. Okay, so now we have solved equation 4. I mean we have already solved question 4. Okay. So that's everything for this video. Okay, so in this section we basically talking about how you actually let me actually move it upwards, sorry. Okay, so in this section we're basically talking about how you actually using the substitution method, right? So at the beginning how we're using the substitution method, and then after that I basically explain about, like, how to actually I basically talking about a property, right? So like what is the difference between those three properties, right? And I also mentioned that we're only gonna focusing on the additional method and then substitution method. Graphing method is inefficient. Okay, so make sure you guys does subscribe to my channel. Okay, make sure you guys does subscribe to my channel. Yeah, and if you still having some question, please leave a comment below. Okay, so please leave a comment below. I would try to answer those questions as fast as I can. Okay, so again, make sure you actually subscribe to my channel. Okay, so make sure you subscribe to my channel. Also like the video. Okay, okay, also turn the notify button on. Okay, turn the notify button on. I will basically keep uploading videos. Okay, yeah, so hopefully you guys does learn something from this video. See you guys on the next video.